Well, welcome to part 2 on the Motorola 51X12. We aren't going to waste no time, we're going to jump right in here. Got the filter capacitors out. This is a 2-section 20 microfarad at 150 volt, both sections being 20 microfarad. And this is the tube that's left from the 20 microfarad 150 volt. Now one of these was supposed to be a 20 microfarad at 25 volt. Well, evidently at one point those had went bad and been replaced, or one of them had went bad and been replaced by a 150 working volt capacitor. So probably what I'm going to do is put the new one back into the old. Of course, fill that up with some packing of some kind. I want to try this whole restuffing thing. This looks like a pretty neat process, and I might be able, I got enough room in there that I could heat shrink some lead, because all I have is the capacitors with leads that come out the end. Then I might be able to bend one back over with some heat shrink and run the leads out the ends just like the originals. And with these, I might be able to put one, end for end if there's enough room in this little tube. Something like so. Time will tell. We'll just have to tinker around with it and see what we got. But during teardown, taking out them electrolytics, I also cut the cord off. It's not rusted in the garbage can. That thing was pretty sad shape. I've come across some wiring here that's rubber that's completely crapicized itself. And this was mashed flat underneath of the electrolytics. This big orange jobby right here. And this one back here is bare. It's got a bare spot that was against the chassis. This one wire goes all the way down to the output, or not to the output tube, to this tube here on the back corner, which would be the it's the 35Z5 rectifier tube back here, and it comes from the 12SA7 oscillator tube up top here. And this other wire, rubber wire, coated wire, comes off at the same 12SA7 tube and comes down and goes to the 12SQ7, which is our detector AVC tube right here. And there's also a, what I believe to be called, a gimmick capacitor underneath of here. All this is a piece of wire that's wrapped around right here. This is the 12SA7 GT in the back. This is our IF amp tube. It's wrapped around this lug right here, and it's wrapped around this lug right here, and it comes over and solders to this lug. This other end's not soldered to nothing. They must have needed just a little bit of resistance in between there. Very, very strange. And somebody has replaced this 0.01 at 100 working volts with a 0.02 at 600 volts line bypass cap. This is not the line bypass cap. This is the line bypass cap right here, which is replaced with a Mylar 0.05 at 600 volt, which it should be a 0.05 at 200 volts. So 600 volt, that ain't gonna hurt nothing. That's okay. This is where our power cord reattaches. So I got some rubber wiring to replace. Long one that goes all the way up top here, and this other one that goes all the way down here. This one in here is this gimmick capacitor or whatever this thing's supposed to be. I shouldn't have to bother that, so I'm not going to mess with him. He looks to be in pretty good shape. See, the end of that is just hanging out. Actually, that is pretty brittle. I might have to get in there and mess with him. Oh well, that's just a matter of unraveling around some pin tubes, and yeah, you can see. How easy that stuff is breaking off. So that might be another reason why we had flicker in that dial light when this radio was in operation too. We had some areas that might have been shorting out. So it's always good to check these good. I didn't find any voltage passing to the chassis, which is good, so nothing was shorted out dead to where we're going to have some faults. But you sure wouldn't want to plug it back in now, because you got a bare wire. Hence the reason why the cord's cut off and thrown in the garbage can. Well, good afternoon, everybody. I hope y'all can hear pretty good. I've got a fan running in the other room downstairs here. Moisture conditions in our basement. It's just due to all the rain we've had here in Ohio. We've probably had upwards of 6 inches of rain in the last week and a half easily, which, you know, doesn't seem like a lot, but when the ground was pretty saturated before all that came along, it's adding up to a good bit. So the basement's kind of damp in spots, and I really don't need that dealing with these old electronics and stuff. It's just going to cause a lot of havoc. Anyway, our Motorola project here. Been doing some scheming, some thinking, some devising, whatever. But I've got some wiring to replace in this old set, some rubber coated wire, as you see in the first part of the video. And I've been looking around for some wire. You go to Radio Shack, I'll tell you what folks, Radio Shack, they don't have hardly anything anymore. And it was determined that the wire in this set is probably right around 20 or 22 gauge, about like that right there. This is stranded. Of course, what's in the set is solid. Stranded will work. This is 18 gauge, 315 foot rolls. It's rated for 300 volts. This will work, but the wire that's in the radio is yellow. I wanted to stay with that wire for identification's sake more than anything else. So I got to thinking, well, somewhere around here I did some wiring in the vehicle a while back, and I bought some primary wire. And I knew I had it in some different colors and stuff. And sure enough, I went out in the garage and looked. I had it in blue, yellow, and green. That's great. I needed the yellow. The yellow will work. This is a little heavier than what the radio has in it. This is 16 gauge. Radio probably had somewhere between 20 and 22. This will work. Should work just fine. It's stranded. And we ought to be able to replace our 2 runs of wire with this. No problem. Another thing I've been working on is the filter capacitor location in this radio is very cramped. And flip this up, see if you can kind of see just a little bit. The original filter capacitors set up here, and this other little 20 microfarad electrolytic set on top of that one. Kind of a configuration like that. It's very odd because one of the 20 microfarads went out to this wire right here and the ground, and the other 2-section 2020 went to this wire right here and out to this tube socket for the positive side, and the negative side again went back to that same ground where the blue one went. So what I'm thinking about doing on this set is actually taking my 2 capacitors like this, joining the grounds, and then running another wire out the other end as a common ground, and mounting them back inside this tube, and then filling the end like I've seen people do before with hot glue. Now I don't have any brown or black hot glue, all I got's clear, but it should do the trick. Now I was going to go all out on this set, and I thought, you know, I've never restuffed the capacitors in any recap I've done. I thought about doing it on this one. And I'm not completely sold on that yet. I might do it, I might not. But I think that's how I'm going to go with that electrolytic right there. Now for the other single section 20 microfarad cap, which these are 22 microfarad at 450 volts. The originals were rated 20 microfarad at 150 working volts, so these should be more than sufficient. The lead that's still out is my positive, the lead that's been over is my negative. Again, I was going to add another wire to this. Same thing here. Slide it inside the tube, and then shim it accordingly so it doesn't rattle. As you can see, it's a pretty decent fit. Then running my wires out the end, filling it over with glue, and then rolling down this crimped edge. I think that'll work pretty good. So we've got our wire, we've got our capacitors. Another thing I noticed in this set is that I pointed this out before in the first video. This Mylar cap right here is a 0.05 at 600 working volts. The original one should have been a 0.05 at 400 volts. This cap is across the line. I don't know if you can see this in this schematic, but it sits right here across the power line. Here's one half of our line cord coming in to the rectifier, through the pilot light to the rectifier. That capacitor joins it right here. The other side of our power line comes into the on volume switch, This is an RF choke assembly. I told you that was like a wire wrapped around a capacitor. That's an RF choke assembly. And then it goes through that choke assembly and connects to our across the line cap back to ground. Okay, well that's been replaced. My question is, that is not an across the line cap. That is just a standard 0.05 microfarad to 600 volt capacitor. It's doing the job, obviously. It's not getting hot. It's not blowing if there's a surge and you turn the power on to the unit. But what's odd, this is supposed to be a 0.01 at, I think, 200 volts. And what this has been substituted with is a 0.02 at 600 volt, and this is a Falcon bypass capacitor. I don't know if it's just something somebody had. This is just supposed to be a standard run-of-the-mill capacitor. There's nothing anywhere on the schematic, be it in the parts list or on the drawing, that specifies that being a bypass capacitor. Now that capacitor should be number 10, and number 10 is right there, right off the volume control. And it connects with a 3.3 mega ohm resistor, and then goes up to pin 2 on the 12SQ7. That has to be some kind of a coupling capacitor. Interesting. So, you know, you run into this stuff when you start redoing these old radios and getting into them. Somebody's been in there before messing around. So, I've got my soldering iron heating up right now. And hopefully we can get this wiring out of here. I'm going to make a pile of all the crap I took out of this set. And I'll review it with you here at the end. And we'll show you how brittle that wire was and how busted up this thing was internally. And it still worked. It still worked, be it did. But be very cautious when powering up these items. Like I said, I went through there, I poked at everything. I knew that that wire was brittle. It was not missing any coating. It's when I removed the capacitors and poked at it that all that coating fell off the side. So you got to be careful doing these things. Well, we're slowly making some progress here. I've got the dual section 2020 rebuilt. Basically all that I did was solder the two negative connections together of the capacitors with a short piece of this 22 gauge wire, and then soldered another piece onto that, and made sure I had good connections on everything. I hooked it up to my capacitor tester, and I shook all this. I wiggled it all around, make sure nothing was loose, everything's good. So this is our basic common ground right here. And when we're done, I'm going to solder a red wire and probably a blue wire onto this. That way I know this is the positive of one of the 22, which should be 20s in the radio. And this is the other positive lead. This is our common ground. So that should work out pretty good. That thing should just, look at there. Looky there. Slides right in there with no problem. Our other capacitor here, our single section 22 UF, which is replacing a 22 UF. I have soldered the new black wire onto the negative of the capacitor. We'll just fold it down here to where it sets. Was going to try to use some heat shrink on this. I don't have any that fits really well. I have some that's smaller than this, and I've got some that's massive, and I don't want to heat shrink the whole capacitor in case I'd ever have to tear it apart. That'd be kind of a pain in the butt. So what I'll do is I'll just use some tape here. We'll go around it a few times to kind of give it a little bit more added strength. There we go. Take our old trusty whisk scissors, snip him off, and there we go. Everything's connected, everything's secure. Let's cut us off an excess length here of lead. Let's do that. We'll strip this back. There we go. And we'll check it with our tester here. We should have right around 20 microfarads, 21 microfarads on these. Not every capacitor is exactly spot on. Our 22 microfarad electrolytic reads 19.8. So move it all around here. We got no variation in that. And I'll show you just for the heck of it our dual section that I built, or my equivalent to a dual section. Here's one half of it, reading in about 19.9. Here's the other section of it, about 19.8. Excellent. So now we'll get some colorful wires soldered to that, and hopefully the next time you see it is before I put it back into the cardboard tube. The glue is setting up inside my new rebuilt electrolytics, I should say. Clear glue. It's kind of neat because you can see the cap down inside of there. If you didn't know any better, to look at it just stock in the radio, that still looks like an old school solar cap, except you got one lead too many on it. Both of these should be coming out down here. It just wasn't feasible. The cap wasn't big enough to run them both out the same end. I made a ground wire for these, and I said I was going to hook a blue and a red wire to the positives. But then I got to looking at the radio chassis, and that really wouldn't make much sense because I don't want to disturb where the positive connections that came off the electrolytic caps connect back into the radio wiring. One of them goes back to a tube socket right here, right in the middle right here. And the other one goes back and around down here to the rectifier tube. I didn't want to mess with that. The leads are long enough. I can solder, I cut back, pigtail solder. I can make them work the way they are. And I don't have to worry about changing them. So that worked out pretty nice. That one's nice and set up. This one over here was still a little soft. That's why he's in the clamp. And we got our proper positive and negative, being the black wire, and the bears are positive for right now until we get back in the radio. Roll the edges down and filter full of glue. I got a slight bit of a lump, like you can see. That's not completely circular like it should be. That's because of my solder joint right up on top here. And basically all I did with this one was wrap it with electrical tape, and that made it thick enough. I just had to add about 1 or 2 more turns after I turned the camera off last time, and it fit right in there nice and snug. And then just filled the voids in, put the tip of the glue gun in there, and filled them in. So there's a look at my rebuilt electrolytics. That'll probably be about it for right now. I'm going to continue to work on this set this afternoon. I'm going to post this up as a video right now, so this is part 2 in the Motorola 51X12 series. Thanks for watching, guys, and more to come later.